Number 60, for cosecant of pi. Cosecant is the inverse of sine, so 1 over sine of pi. Sine of pi, pi is all the way over here. Sine is the y-coordinate, so I have a 0. I can't have a 1 over a 0, so therefore there is no solution to number 60. 61, if you have a circle that has a radius of 5, and this is a 60-degree angle, and you want to know what this arc length is, then you use that the length of the arc is equal to theta, or the degrees, times the radius. But this has to be in radians. So I have to change that 60 degrees into radians by multiplying by pi over 180. These cancel to a 3, so I really have pi over 3. So the length of this arc is really pi over 3 times 5, or 5 pi over 3. Number 62, cosine, inverse cosine of square root of 3 over 2. That means where on your unit circle does cosine equal square root of 3 over 2? Cosine is the x-coordinate, and I see two places, here and here. So that's both at 30 degrees and 330 degrees, or pi over 6, 11 pi over 6. So that's 30 degrees and 330 degrees, or pi over 6 and 11 pi over 6, plus every 360 degrees that you go around. 63, for capital sine, you're specifically looking between negative 90 degrees and 90 degrees. So if you put that, if you look at your unit circle, you are looking only at this half for a capital sine. And where does it equal negative square root of 2 over 2? Well, that's right here. It's at 315 degrees. Or, because it has to be negative 90 to 90 degrees, then that's negative 45 degrees. 64, where does tangent equal the square root of 3 over 3? Tangent is equal to y over x, or sine over cosine. And square root of 3 over 3 happens when you put 1/2 over square root of 3 over 2. So that must mean that we're at 30 degrees. Capital T refers, again, same thing as sine, to this half of the circle, while a capital C for cosine refers to the top half of the circle. 65, if you have sine theta equals 0.6, then you want to move the sine to the other side so you can get theta by itself. So you take the inverse sine of 0.6, and you do that using this button here. So you'll go second inverse sine of 0.6, and you get 36.9, which does fall in that interval that they give you between negative 90 and 90. So that's fine for your answer. For 65, if you're looking for cosine theta equals 0.4, again, you're going to do inverse cosine of 0.4, and when we do inverse cosine of 0.4, we get 66.4. However, that number is not in our interval. Our interval, they said, was from 270 degrees to 360 degrees. So if you look at your unit circle, if this is 66 degrees here, that's the angle that you think you're looking at, but since you want to be in this interval, you really want to flip that into the correct quadrant. So this would also have to be 66 degrees, or if you're talking about in a 360 degree circle, you'd subtract 66.4 degrees from 360, which gives you 293.6 degrees. Number 67 and 68, you're looking for area of a triangle. You have, if it's not a right triangle, it's 1/2 base times height. But you have another formula that says you can do 1/2 BC sine A, meaning as long as you have a side angle side where the angle doesn't match to the other side that you have, you can use this formula. So this is really 1/2 of B, or let's call that 3, times 7 sine of 35. If you put that in your calculator, you get 6.02 for your area. Same thing over here. You can also use 1/2 BC sine A, but you don't have a side angle side. You do have side here. You need this angle over here. You don't know it yet, but since you have a 25 and a 35 here, angles in a triangle add up to 180. So this is really 120 degrees, so you can find that pretty easily. So now you can do a side angle side, or 9 times 8 times sine of 120, so 0.5 times 9 times 8 sine 120 gives you an area of 31.2. 69 is a triangle that you can use law of sines for. So sine of 40 over 5, so that's the corresponding angle on the corresponding side is going to be equal to the sine of the corresponding angle here, so sine of 50 over, we're going to call this side B, this is side C. If I have to solve for B, I need to multiply B to both sides, which clears this, and then I have to get this to the other side, so I multiply both sides by the reciprocal of that, or 5 over sine 40. So if I do that, 5.96. And that's for side B. For side C, you're going to do the same thing. So sine 40 over 5 is going to equal sine C, which, because this is 50 and that's 40, then this must be 90. So sine of 90 over C. C is going to equal sine of 90 times the reciprocal of this, which is 7.8. For number 70, you have a side angle side, and if you're trying to find everything else, you're going to need to use law of cosines for this. Law of cosines tells me that if this is C, B, and A, and I really know angle B, that B squared equals A squared plus C squared minus 1 minus 2 AC cosine of B, and that will work for any of your triangles. You can rearrange these letters to suit your needs, as long as this B and this B are the same, or this is A and this is A, this is C and this is C. For A, it looks like we have 6 squared plus 8 squared minus 2 times 6 times 8 cosine of 45. This is 100 minus 96 cosine of 45 adds up to 32 point. For your B squared, you have to square root both sides to get your answer, which is 5.7. B equals 5.7. If that's 5.7, now you have a law of sine situation where you have sine of B over the side B is going to be equal to sine of, let's say, A over 6, the corresponding side to that. I multiply 6 to both sides, so my sine A be about 0.74. I'm going to take an inverse sine of both sides, and I get about 48 degrees-ish. If you're a little bit off, just rounding errors on my part. So I have 45 degrees here, I have 48 degrees here. I know that all three sides have to add up to 180, so I can find my third side by subtracting 48 and then subtracting 45 minus 48 minus 45 means that my angle C is equal to 87 degrees. Last one. 5, 6. If this was 15 like it says in your paper, that would be impossible because these two sides wouldn't be long enough to make this 15. So let's try this with a 10. If we do law of cosines again, you would have 10 squared equals A squared plus B squared minus 2 times A times B cosine of C. So I'm looking for cosine of C this time. This is 100. 25 plus 36 minus 60 cosine C. I subtract these two from both sides to get 39 equals negative 60 cosine C. I divide both sides by negative 60 to get negative 0.65 or 0.65. And then I take the inverse cosine of that. So C would equal 130.5 degrees. You're going to use law of sines again to solve this, so that sine of 130.5 degrees over C, or 10, is equal to something sine B over 6. If I multiply 6 to both sides, 6 times the sine of 130.5 all over 10 is going to equal 0.45 equals sine B, or B is going to equal the inverse of the inverse sine of that, and that gives me 27.1 degrees. 130.5, 27.1, they have to add up to 180. So because those two add up to 157.6, then my angle A has to equal 22.4 degrees. And that's it. I hope this was helpful.